Welcome everyone. So we will solve now the Neet 2021 paper, the physics part. Okay, this is the paper code O6. So let's begin. The first question: electron concentration in an N-type semiconductor is the same as hole concentration in a P-type semiconductor. So basically, I have two semiconductors. One is N-type, the other one is P-type. Now an external field electric is applied across each of them. So what does this mean? Electric field is applied means I must have connected it to a cell. So I am going to get current in both the cases, right? And let's now make an assumption here that the voltage of the cell is the same, or basically the electric field is the same. So if I want to compare anything, then I should also consider they have told us that um, the concentration is the same, the doping level is the same. We should also assume that the voltage is same. We should also assume the size of the semiconductor is the same. Okay. Keeping everything the same, what can we say about the current? So current in N-type more than P-type, or no current will flow in P-type, current will only flow in N-type. Okay, so or is it equal or P is more? So we know this that the drift velocity, right? The mobility of the electrons is going to be more than the mobility of holes. And in N-type, we have more electrons, and in P-type, we have less number of electrons. So we can now say that in N-type, we should have more current. So we can select, right? Current in N-type should be more than current in P-type. So that would be N-type is more, so it should be the first option. Okay, then the next one. Question number 2. So this was number 1. Let's solve number 2. So question number 2: a small block slides down a smooth inclined plane. So we have an inclined plane and the block is sliding down. Okay. So we know the acceleration of a sliding block is g sine theta. And we can resolve the weight mg into two components, mg cos, and this one is the one of interest here, mg sine. So my acceleration is going to be g sine theta, right? And it is the same for both of them. So now both of them in the sense that for both the time intervals, they have said starting from rest. Now there are two time intervals, Sn and then n plus 1. So Sn means the distance traveled by the block in the interval n minus 1 to n. So what does it mean by the, let's say the distance traveled by the block in the first second. So first second is 0 to 1. Second is 1 to 2. Third second is 2 to 3. Similarly, the nth displacement here would be n minus 1 to n. So we now have a direct formula for Sn, right? And that is u plus a by 2 to n minus 1. The initial velocity is 0 because it starts from rest. That is very clearly told to us, starting from rest at t equal to 0. So what is the ratio of Sn and Sn plus 1? So this is now very simple because this acceleration is the same. So when I said, is the same, this a is constant, d sine theta, it is the same whether whatever time interval it is. So u is 0 and a is constant. So let's just keep it as a. So all I need to worry about is this n. So Sn is a by 2 to n minus 1. And if I want to divide it by Sn plus 1, right? So bring the equal to sign here. And we say divide by a by 2 is going to remain the same 2 times. Now instead of n, we have the next value, that is n plus 1. And then again minus 1 has to be done. So now this a by 2 and a by 2 is going to get cancelled off. So numerator is going to be 2n minus 1. Denominator is going to be 2 times n plus 2 minus 1 is plus 1. So that's it. I get my answer. Going to be 2n minus 1 upon 2n plus 1. Very simple. Okay, the third one. So the third one is the escape velocity from the Earth's surface is v. So what we call as ve, that is v. Escape velocity from surface of another planet having a radius 4 times. So radius of the planet is 4 times the radius of Earth, right? And the same mass density. So density of the planet is the same as density of Earth. Okay, fine. So we want to talk about escape velocity. So let's just use VE. So VE formula is 2g capital M by R, surface of Earth, radius of Earth and mass of Earth. Now, what we can do is we can replace this mass with density into volume. Volume of the Earth as a sphere would be 4 by 3 pi R cube. So I'm going to get R square, right, under root. So now, if I want to replace equal to sign with proportional sign, then I can say escape velocity is going to be 2 is going to be a constant, so remove it. G is a constant. Density is the same, it remains a constant. 4, 3 pi are constants. Root of R square is R basically. So square root of R square is R. R is the only thing which is changing here. So escape velocity on Earth upon escape velocity on the planet, let's call it as Vp, would be radius of Earth, Re, and radius of the planet is 4 times Re. So I'm going to get Vp is going to be 4V. So Vp, so escape velocity from the planet is going to be 4V. Okay, fine. Question number 4, the theory type question. A dipole is placed in an electric field as shown. In which direction will it move? So you can see very clearly I have a positive charge and a negative charge here. Okay. This is what kind of a field? This is a radial field. Please understand, radial field always starts from a there must be some positive charge here because it's going out. The lines of force, electric lines of force are going out. So it must be some plus Q, or let me say capital Q. So if there is a capital Q charge here, this positive charge is going to face a repulsive force, whereas this negative charge here is going to face an attractive force. But this negative charge is little bit away further from the positive charge than compared to the positive charge. So the repulsive force will be more, attractive force will be less. So the net force has to be in this direction, right? Repulsive force means towards the right. So where will it move? Towards the left, I will not select this. Towards the right makes sense. But what about its potential energy? Will its potential energy increase or its potential energy will decrease? So if I move this dipole to a farther point, say here, right? From here it comes to here, plus Q minus Q. Then what is going to happen is the potential energy of the system as a whole will reduce, right? Potential energy always by default it wants to be at a lower potential energy. So uh, it should be this one will decrease. Okay, the fifth one, simple RLC series circuit is given to us. So voltage on the inductor, inductor L, capacitor C, resistance R are connected in series as shown to an AC source of potential difference V volts. Okay. Now potential difference across L, C and R. So L is 40, yes. C is 10, okay, and V is 40 again, okay, fine. The amplitude of the current flowing through the series circuit is 10 root 2. So this is the RMS current we can assume. So what is the impedance of the circuit? Okay, fine. So what we can do here is, this is question number 5, or we can just copy the diagram again. So let's keep this here. So question number 5. So we have IRMS is 10 root 2 ampere. What we need here is the impedance of the circuit. So we can draw the phasor diagram, right? The phasor diagram would be for the voltage, right? This would be the 40 volts across the resistor. In inductor, the voltage leads. So I will have 40 volts upwards. Right? Capacitor voltage lags. So compared to the resistor. So it would be 10 volts downward. So the resultant of these two would be 30 volts up. Right? 40 minus 10, 30 volts. So if that is the case, then what would be the applied voltage V here? So this side is 40, this side is 30. So then this side has to be 50, 3, 4, 5, right angled triangle, right? This is 40 here. We have 30, right? And so the hypotenuse has to be 50. So the applied voltage V is 50 volts. So let's say the VRMS, right? The VRMS is 50 volts and IRMS. So Z is going to be VRMS over IRMS. So I'm just going to get 50 upon 10 root 2. So it's going to be 5 by root 2 ohms. That would be the impedance. Okay. Next one. Polar molecules are the molecules that acquire a dipole moment only when magnetic field is absent. Having a permanent electric dipole moment, yeah, that makes sense. Having zero dipole moment, no, then they are non-polar. And acquire a dipole moment only in the presence of electric field due to displacement of charges. So it should be, even if the field is absent, there should be a, dipole moment. So option 4 says only in the presence of electric field, whereas option 2 says then it has a permanent electric dipole moment. So I think the second one here is more correct. Right? Okay, number 7 is a screw gauge question, but it's very simple. A screw gauge gives the following readings, right, when used to measure the diameter. So the main scale reading is 0, okay, fine, and circular scale is 52 divisions. Now given that 1 millimeter on the main scale corresponds to 100 divisions. So if 100 divisions, 7, if 100 divisions is 1 millimeter, then 1 division is how many millimeters? So let's call that as x. So that would be, that x value would be 1 upon 100 millimeter. Okay, that is the value of x. And how many divisions do we have in the reading? The reading has 52 divisions, circular scale reading, and 0 mm. So the main scale is 0, and the circular scale is 52. So what do we get? 52x. So my diameter will be 52x, right? Because with a screw gauge we can measure the diameter. So 52 over 100 millimeters, so 0.52 mm, that is 10 to minus 3. But the answer is in cm. So I should absorb one negative power. So I will have 0.052 into 10 to minus 2. Okay? Or this will become 0.052 centimeters. Right? So it should be 0.52 centimeters, that is 2. Okay. Number 8. So half-life is 100 hours, and they're asking the fraction of the original activity that will remain after a time of 150 hours. So very simple, let's just use the formula n is equal to n0 e raised to minus lambda t. So what they want is n by n0. Right? N by n0 is e raised to minus lambda is natural log of 2, or if you want you can write it as log to the base e to make it very obvious that it's the natural log, right, of 2 divided by the half-life, which is 100, into the given time, which is 150. So this will be 50 2s are 50 3s are. So I have e raised to log to the base e of 2, and then I have minus 3 by 2, minus 3 and 2, right? Minus 3 by 2. So that I can take it, I can write it as a power of 2. So this will basically become, so this e raised to log to the base e will basically, what will remain is this number 2 raised to minus of 3 by 2, or it's nothing but 1 upon 2 cube is 8, and square root of raised to half is square root. So I will have 1 upon 2. So that's it. That is the 8th one. So that was the first page. Okay, let's go to the second page. So question number 9, the number of photons per second on an average emitted by the source of monochromatic light of wavelength. So lambda is given to me 600 nanometers. So they want the number of photons per second, right? When it delivers the power of 3.3 into 10 raised to minus 3 watts will be how much? And H value is given to us. We know it anyways. It is 6.6 minus 34. Fine. So what is power? It's work or energy upon time. And energy is because of some n number of photons, and each having energy hc by lambda divided by time. So therefore, this number of photons per unit time, that's what we want, right? The number of photons per second. Number of photons per unit time would be the power into lambda upon hc. That's all. So power is 3.3, 10 raised to minus 3 into lambda, which would be 600 nanometers is 6 into 10 raised to minus 7. H is 6.6, 10 raised to minus 34, and C is 3 into 10 raised to 8. So 3.32s are, and again I have 3 2s are 6. So minus 34 plus 8 will give me minus 26 will go in the numerator, will become 10 raised to 26, right? And then I have minus 3 minus 7 is minus 10, so I will be left with 10 raised to 16, which is option 1. Okay, the next one, number 10. For a plane electromagnetic wave propagating in x direction, which of the following combination gives the correct possible direction for the electric field E and the magnetic field B? Okay, fine. So combination of electric and magnetic. So the direction of propagation is x. So what we could do here is we have to consider the xyz directions. Okay, so it will involve a little bit imagination. Okay, so this is where the wave is propagating along x. Let's call this is y and z. So now the first option says j plus k, j cap plus k cap. So j cap would be upwards like this along y, k cap would be here. So j cap plus k cap would mean a vector like this, and minus j cap. So okay, I'm just talking about option A. Okay, option A. So I would have electric field here, and then minus j cap minus k cap would be somewhere here, right? It would also be in the YZ plane, but this will result in the electric field and the magnetic field being not at right angles to each other, but actually 180 degrees to each other. So option A would not make sense. Okay, because the electric field, the magnetic field, and the direction of propagation must be perpendicular to each other. Okay, so let's look at option 2. Option 2 says minus j cap. Okay, so minus j would be down, and plus k would be here. So I will get the electric field somewhere here. Let's say for example, right? E is here, and then the magnetic field would be minus j plus k, again in the same. No, that's not possible. How can they both be the same? So that's gone. Option 3 is also gone, j plus k, same. It should not be the case. Option 4, we should check that. So minus, I mean, that's the only option which is remaining, but still let's verify. Minus j plus k. So minus j plus k would be here. And minus j and minus k would be somewhere here. Yes, and now I can have the E bar and B bar at right angles, right? The E bar is at 45 degrees to the Z axis, right? I mean, if you view from this side, right? If you look at the YZ plane, then it's like for the YZ plane, it is in the third quadrant, and B bar would be in the fourth quadrant of the YZ plane, right? Fourth quadrant of the YZ plane. Don't confuse it with X. So they will be perpendicular to each other. So the fourth option makes sense here. Okay, the next one. Number 11, the velocity of a small ball of mass m and density d, okay, when dropped in a container. So let me just make some space. Yeah. So it is dropped in a container filled with glycerine. Okay, so I have a container of glycerine and a ball of mass m, density is d. Okay. So when dropped in a container filled with glycerine becomes constant after some time. Yeah, so it attains terminal velocity. So if the density of glycerine is d by 2, okay, fine. So glycerine is d by 2, the liquid. Okay. So what is the viscous force acting on the ball? So we need to find out the viscous force acting on the ball. So viscous force, the formula is given by Stokes law, 6 pi eta r v, and we want it in terms, the answer should be in terms of mg. Okay, fine. Okay, so since the answer is in terms of mg, then the 6 pi eta rv is not going to help us actually. So what we should think is we should draw the fbd of the ball. Downward is mg and upward is equal. When it achieves terminal velocity, it is equal. Upward force is equal to the downward force, but the upward force is made up of two components. One is the buoyant force and one is the viscous force. So the viscous force plus the buoyant force is equal to mg. So the viscous force is going to be mg minus the buoyant force. So obviously it has to be less than mg. Right? So you can see very clearly there is, actually speaking, only one option here which is less than mg, and that is mg by 2. 2 mg is more, 3 by 2 mg is more. Mg, it can't be equal to mg, otherwise the viscous force will become 0. Right? So it has to be mg by 2. There is nothing to solve here. But still, if you want to prove it, okay, what if there were multiple options? So let's prove it. So it's going to be mg. So you could have saved time here if you knew, if you had looked at the options. Right? Mg minus something has to be less than mg. So buoyant force would be density of the fluid, which in this case is d by 2, into volume submerged, entire volume of the ball. So what is volume of the ball? So density is mass upon volume. So volume would be mass m upon density d of the ball, right, into g. So I have mg minus mg by 2, which is mg by 2. Okay, so we just proved that. Then number 12, parallel plate capacitor has uniform electric field E in the space between the plates. If the distance between the plates is d and the area of each plate is a, then the energy stored in the capacitor is, oh, we already know the formula for the energy stored in the capacitor. So energy stored inside the capacitor is, you have three formula, half CV square, or they want the answer in terms of electric field. So electric field is there in all four options. So let's use half CV square. Okay, half C V square. First of all, the C value can be written as epsilon naught A. Let's assume air field, right? They have not said anything. Yeah, they have not said anything. So epsilon naught we'll consider. Epsilon naught A, K is 1 by D. This is the C value. Now this, we don't want a V, this term V voltage in the answer. So we will write it in terms of electric field. So, if you compare the electric field versus electric field due to a charge and electric potential V. So the relationship between E and V is that E is 1 upon 4 pi epsilon naught Q by R square, whereas V is 1 upon 4 pi epsilon naught Q by R. So this V divided by R or divided by D will give me E. So V by D is E, or in other words, V is equal to ED, or E is V by D, you can use square. So I will get 1 by 2 epsilon naught A E square D square by D. So I'm going to get epsilon naught A E square D by 2. So is it matching with anything? Let's check. There is a divide by 2 epsilon naught A E square D by 2. So this is matching with the first option itself. Okay. Yeah. So the next one is number 13. So use a new page. Okay. So column 1 gives certain physical terms associated with flow of current through a metallic conductor. Drift velocity, electrical resistivity, relaxation period or relaxation time, and current density. Okay. Column 2 gives some mathematical relation involving the electrical quantities and match column 1 with column 2 with appropriate relation. Fine. So we need formula basically. So if you look at the options carefully, all 4 options have A is matching with R. So that means we don't need to bother about A. We don't need to bother about R. Fine. Then also if you see carefully at the last one, D is either Q or P. Q, P, Q, P. That means D is not S. So if D is not S, neither one of these is S. Okay, B or C. Right? So here C is S, and here in these two, B is S. Okay. So let's think about that option, the column 2S. S is basically E by J. Just now in the previous question, we saw electric field. The units can be written as volts per meter. E is V by D, volt per meter. And J, the units for J, current density, is current upon area. So upon goes in the numerator, area goes in the numerator. So I get volt upon current, voltage upon current, which is ampere, ohms, ohm meter. An ohm meter is nothing but resistivity. So what we could do is, instead of this, we can write A is R. Okay, so this is 1, and resistivity is S. B is S. So this is 1. So that means I'm left with these two options. C is not S. B is S. Now I'm having two things remaining now in column 2. Let's find this out. This is easier to deal with. It looks easier. So we have NEVD. N is your number of charges per unit volume. So it's a number upon volume. So upon volume is meter cube in the denominator, right? Charge is in coulomb, and drift velocity is in meters per second square. Sorry, meter per second. So this meter gets cancelled off. So I have coulomb per second and then meter square. Okay. And now what we could do is Coulomb can be written as, because I is Q by T. So Coulomb, the charge, Q is IT. So ampere into second. So second gets cancelled off. And I'm left with ampere per meter square, and ampere per meter square would be current density. That means D is Q. So if D is Q, then the only one remaining is C. It has to be P. So RSPQ will match with option 3. Okay. Number 14. In a potentiometer circuit, a cell of EMF 1.5 volts gives a balance point at 36 centimeters. So E1 is 1.5 and its corresponding L1 is 36 centimeters. If another cell of EMF 2.5 volts, so E2 is 2.5 volts, replaces the first cell. So replaces means it's not a combination cell method, it's individual cell method. Then at what length of the wire the balance point will occur? Oh, very simple. E1 by L1 would be K, and it would also be equal to E2 by L2. So what would be L2 therefore? L2 would be E2 L1 by E1. This simple cross multiplication. L2 goes here, L1 goes here, E1 in the denominator. So what do I have? E2 is 2.5 upon E1 is 1.5 into L1 is 36. So 25 by 15. So 5 3s are 5 5s are, and I have 3 1s are 3, 3 2s are 6. So 12 5s are 60. Okay. This was number 14. So number 15 now. So the effective resistance of a parallel parallel connection that consists of 4 wires of equal length, equal area, in same material. Or if they have same length, same area, same material, that means they have same resistance. Rho L by A, R is rho L by A. So rho is same, material is same, length is same, area is same, so resistance is same. And if I have 4 of them, then the RP is going to be R by 4. And that is 0.25, which is 1 by 4. That means each wire is of 1 ohm. So what will be the effective resistance if they are connected in series? So 4 ohms. 1 plus 1 plus 1 plus 1, 4 times. Okay, so this was the second page. So we go to the third page of the paper. We can just crop it a bit. Okay. So number 16. An infinitely long straight conductor carries a current of 5 ampere as shown. What is shown? Okay, so there is a wire PQ which is carrying a current of 5 ampere. Okay, fine. An electron is moving with a speed of 10 to 5 meters per second parallel to the conductor. Okay, so there is an electron which is moving parallel to the conductor with a speed of 10 raised to 5 meters per second. At the perpendicular distance between the electron and the conductor is 20 centimeter at an instant. So at this instant of time, the distance here is 20 centimeters, or let's say 1/5 of a meter. So calculate the magnitude of the force experienced by the electron at that instant. So at this instant, what is the magnitude of the force? So I can say QVB sine theta, right? This is QVB sine theta, where theta is the angle between V bar and B bar. So V bar is very clear in this direction. And where is B bar? So according to right hand thumb rule, if I imagine the wire PQ in my right hand, so my thumb is pointing towards the right because they have shown us the direction of current from P to Q. So the lines of force would be circular. So at this point E, right, if these are the lines of force, then the tangent here would be coming out. So if I have an outward tangent and the electron is going this way, the angle is 90 degrees. So sine 90 is 1. So the magnitude of the force is simply going to be Q, which in this case is E, V, and I need to find out now the value of B at this point. So for that I will use, it's an infinitely long straight wire, so I will use the formula mu 0 I upon 2 pi and the distance, if you call it as A. So the value is going to be E, which is, let's put the numbers now. So 1.6, 10 raised to minus 90. V is 10 raised to 5. Mu 0 is 4 pi into 10 raised to minus 7. I value is 5 amperes. 2 pi and A, the distance A is 1 upon 5, 1/5 of a meter. Okay, so we have 2 pi, 2's are 4 pi. So 5 goes in the numerator, becomes 5 as a 25, 25 into 2 is 50. So I have 1.6, let's make that as 16, and 50, let's call it as 5. So we took the 0. So 16 into 5 into, there is no other number that remains. So I'll have 10 raised to minus 19. And minus 7 will give me minus 26. Minus 26 plus 5 will give me minus 21. So, or let's call it as 16 into 0.5, which is half, into 10 raised to minus 20. So I'll get 8 newtons. So 8 into 10 raised to minus 20 is option 2. Okay. Number 17, E and G respectively denote energy and gravitational constant. Then E by G has what dimensions? Okay. So energy is very clear. We know the dimensions for energy, but this G, what is gravitational constant G? So if I use the formula F, force is G m square upon r square, yeah? Gm on m2 upon r square. So then G is going to have the units of Newton meter square per kg square. So that I have to keep in the denominator, and the numerator is energy. So energy, let's take any form of energy. Let's say suppose mgh. Let's solve the 17th one here itself. So if I have mgh, so mass m g meters per second square, right? Acceleration due to gravity. Mgh is in meters. This is my energy divided by Newton, which is again a force. So again ma, mass into acceleration. So again kg meters per second square, right? That is Newton. Meter square per, going the numerator, kg square. So okay, let's start cancelling off. So we have kg gone, meters per second square gone. So I'm left with 1 meter in the denominator and kg square in the numerator. So kg square will give me mass raised to 2, and meter in the denominator will give me length raised to minus 1. So mass raised to 2, length raised to minus 1, and nothing for time will give me third option. Okay. So we move on to the next page, and still on the third page of the paper. So we now have number 18. So an electromagnetic wave of wavelength lambda is incident on a photosensitive surface of negligible work function. Okay, very important. Work function phi naught is negligible. So if mass m mass is of photoelectron emitted from the surface has a de Broglie wavelength lambda d, then what is the relation between lambda and lambda d? Okay, fine. So we can find out the velocity of the electron, right? Half mv square, half mv max square, or half mv square is incident energy is hc by lambda minus work function, but that work function is negligible. So is approximately hc by lambda, right? Half mv square, because phi naught is negligible. Fine. So how do we bring de Broglie wavelength here? So let's say m square v square by m, or I'll get half p square, momentum square, right, is hc by lambda. And as per de Broglie's hypothesis, we know that lambda de Broglie wavelength lambda d is h upon p, or p would be h upon lambda d. So I will have half or 1 by 2m, and p square would be h square upon lambda d square is hc by lambda. So when one h will get cut. So we want lambda equal to something in the first three options and lambda d equal to this. So let's write lambda equal to something, because lambda d square is going to remain. So I'll have lambda is equal to c remains in the numerator. 2m comes into the numerator, lambda d square comes into the numerator, and this h goes in the denominator. So I have just rearranging the terms, 2mc by h into lambda d square. So 2mc by h into lambda d square, this is matching with the very first option. 2mc by h lambda d square, yes. Okay, that was number 18. So let's do number 19. A radioactive nucleus X, atomic number Z, mass number A, undergoes spontaneous decay in the sequence. First, it becomes B, an element B, whose nothing is mentioned about A, so only Z becomes Z minus 1. So it can't be an alpha particle. Okay, it cannot be an alpha particle. So because if it was an alpha particle, then something should have been mentioned about A. Right? Z is the atomic number element, right? Possible decay particles in the sequence. And anyways, if it was an alpha particle, then it should have been Z minus 2. So because it is Z minus 1, option 3 and 4 are 1. Now after that, it becomes Z minus 3. So again, it is reducing by 2. So then again, alpha has to be in between. So yes, the first two options match. So now I just have to figure out whether it is a beta plus or a beta minus. So at the beginning, so here you can see that the atomic number Z is reducing by 1. Okay, that means the number of protons in the nucleus is reducing. That means a proton must have split into a beta plus particle and a neutron. So the number of neutron would increase by 1, number of proton would reduce by 1, so the A will remain the same, right? And because the proton went away and it became a neutron, and right, and that beta plus particle is emitted out, so it should be this option. And then let's just verify. After that, again, what is happening is Z minus 3 becomes Z minus 2. That means the number of proton is increasing by 1. Minus 3 became minus 2. So it increased by 1. That means a neutron must have split into a proton and um, negative beta particle. So because the number of proton increased by 1, right, minus 3 became minus 2. Right? So beta minus later on. So the first option again makes sense. Okay, so number 20. Body is executing simple harmonic motion with frequency n. Okay, then the frequency of its potential energy is how much? Okay, so we can look at the graph for number 20. we have this graph of position on the x-axis, and which energy are they talking about? Potential energy. So it's potential energy on the y-axis. So at the mean position, we have zero potential energy, maximum kinetic energy. And at the extreme position, let's say A, I have maximum potential energy. And then again at minus A as well, we have the maximum potential energy. So let's talk about one cycle. So in one cycle, I start from the origin, mean position, go towards one extreme. So the energy, right? If I plot a graph of energy versus time, then what will I get? Energy will increase and come back to zero. So if I just draw energy versus time, okay? So let's say we divide into 4 parts. Yeah. So this is T by 2. So from mean position to extreme position is 1/4. So energy goes from 0 to maximum. And then again it comes back to 0 at T by 2. And then again it goes to maximum. And then again at the end of one oscillation, but that because it is energy, it remains positive. That means this graph is repeating itself after T by 2. That means its time period has become half. So the frequency would double. So if the SHM frequency is N, then the potential energy will have a frequency of 2N. Okay. 21. Spring is stretched by 5 centimeters by a force of 10 newtons. Okay, so we can write question 21. F is minus kx. I guess we can ignore the negative sign, yeah, because nothing is mentioned about the sign here. So the force is of 10 newtons. Again, force is of 10 newtons, and spring is stretched by 5 centimeters. So I will get the k value. So force is of 10 newtons and 5 centi. So the k value becomes 10 upon 5 into 10 raised to minus 2 will go in the numerator, will become 10 raised to plus 2. So I have 200, right, Newton per meter, you can say. Okay, 5 centimeters and 10 newtons. Okay, now the time period of oscillation when a mass of 2 kg is suspended by it. So what we want now is the time period. Okay, so we can use the formula for time period. So that would be T is equal to 2 pi root of m by k, which is k value we found out is 200. And what is the m value? Mass of 2 kg. So 2 by 100. So root of 100 is 10. So 0.2 pi. 2 by 10 is 0.2. So 0.2 pi would be 3.14. Double of it is 6.28. Divided by 10 would be 0.628. Okay. So we can now do 22. A nucleus with mass number 240 breaks into 2 fragments, each of mass number 120. Okay, so let's say there is some x which is of 240 breaks into y and z, each of 120. The binding energy per nucleon of unfragmented nuclei is 7.6 MeV. So this fellow has 7.6 MeV per nucleon, right? It's binding energy per nucleon. While that of the fragments is 8.5. So both of these have 8.5 MeV. the total gain in the binding energy in the process is how much. Okay, so let's find out. So for the LHS, we have 240 nucleons and we have 7.6 MeV for per nucleon. So we get the total as this much. RHS, we have the same number 8.5. So again, it's actually 240 into 8.5. Right? 120 into 8.5 plus 120 into 8.5 will give me the same 240, 120 common. So, sorry, 8.5 common. So 120 plus 120 will give me 240 into 8.5. So the difference is going to be, okay, the difference of energy, or the difference of binding energy, if you want to call it as, is going to be 240 into 8.5 minus 240 into 7.6. So I'm going to get 8.5 minus 7.6, which will be 240 into how much will this be? 7.6, so 0.4 and another 0.5 is 0.9, or it will be 224 into 9. So 36, 19, 216 MeV. So it's very simple. It's just going to be option 2. Okay, then we have 23. A lens of large focal length and large aperture is best suited as an objective of an astronomical telescope. Yeah, that's true. Why? Because a large aperture, that is a diameter, contributes to the quality and visibility of the image. Yes, that is true, because large diameter will give me a higher resolution. Right? Or resolving power will reduce, or resolving power will increase. The limit of resolution will reduce. Right? So the quality of the image, it will increase. So option 1 is right. Option 2, a larger area of the objective ensures better light gathering power. Yeah, so more rays, that's also true. Number 3, a large aperture provides a better resolution. Yeah, it's the same thing as option 1. So obviously it's going to be all of the above. Okay, then let's do 24. A convex lens A of focal length 20 centimeters. So let's say FA. Please note convex lens. So plus 20 centimeters. And a concave lens B of focal length 5 centimeters. So if B is concave, so minus 5, are kept along the same axis with a distance d between them. So there is a gap, so its lens is not in contact. If a parallel beam of light falling on A leaves B as a parallel beam, then what is the distance? So basically they're F equivalent. So you have a convex lens and a concave lens. Parallel converges and diverges and becomes parallel. That means the F equivalent focal length is infinity, because equivalent focal length is where they meet. And where do parallel rays meet? They meet at infinity. Yeah, okay, so I can use the formula 1 upon F equivalent is going to be 1 upon F1 plus 1 upon F2 minus D upon F1 F2. So 1 upon infinity is going to be 0. 1 upon F1 is plus 20 minus 1 upon F2, because the B value is minus 5. So plus 1 upon minus 5 will give me minus 1 by 5, minus D upon 20 into again minus 5 I put, I'll get plus 5. So I will get D by 100 is going to be, let's take this 1 by 5 on the other side, will come plus 1 by 5 minus 1 by 20. Let's take LCM 20, we'll get 5 4s are 20, 21s are, so 4 minus 1 is 3 by 20. So if D by 100 is 3 by 20, D is going to be 3 into 100 upon 20, 5s are 15, right? And everything is in centimeters, so it should be the distance D in centimeters will be 15. Okay, so fourth page. the equivalent capacitance of the combination shown in the figure. Okay, so please note this capacitor C here has been shorted. Okay, so whenever there is a short circuit, you can just ignore this. So I have C parallel C, so it's going to be 2C. Very simple. A capacitor of capacitance C is connected across an AC source of voltage V given by V is equal to V naught sine omega t. Okay, so the displacement current between the plates of the capacitor would then be given by. So here we can use 26 displacement current or conduction current, whatever it is. So I, we have to find out this current I. So we can basically use the formula C is equal to Q by V, or let's say dQ by dV, or dQ is equal to C dV. Let's integrate, or if I divide by time on both the sides, so dQ by dt would give me I. Would be, let's take derivative of V with respect to time. So the voltage is V naught. So I have to take derivative of sine omega t, which would be omega cos omega t. So I would get C V naught omega cos. So I need cos, means it has to be these two, and C V naught omega. So that is matching with option 3. Okay, then 27. So consider the following statements A and B and identify the correct statement. So a xenodiode is connected in reverse bias when used as a voltage regulator. Yeah, that is true. We always use xenodiode in reverse bias actually, and it can be used as a voltage regulator. The potential barrier of PN junction lies between 0.1 to 0.3 volts. So the number 0.1 to 0.3, this would, well, it can be 0.3, but only for germanium. For silicon, it is barrier is 0.7 volts. So B is not always true. It's true sometimes, or it's true with a condition. So then A is definitely correct. So if A is correct, then it can be 4, it can be 2, it has to be 1 or 3. This is kind of controversial now. A is correct and B is incorrect. Both are correct, but the option B is only true with a condition. Okay, that it's not silicon. And even if it is germanium, 0.3, 0.3 is the value for germanium. So would it be 0.1 or 0.2? That would also not be true. So I think, we'll just say with option 1 that A is correct and B is incorrect, because B is not always right. That's why B is incorrect. Okay, number 28. So a thick current carrying cable of radius r carries a current I uniformly distributed across its cross section. Variation of magnetic field B due to the cable with distance r from the axis of the cable. Okay, so this one is very simple. You need the formula for the B value inside the wire, right? Inside a thick part, inside a solid cylinder. So for that, the B value is going to be proportional to R. B inside is directly proportional to R. The formula is B inside is mu 0 I upon 2 pi capital R square. Mu 0 I R into 2 upon 2 pi capital R square. So it's directly proportional, and outside it is inversely proportional. So directly proportional means as long as I reach the surface, right, it's increasing and then it's decreasing. So best option here is number 1. Okay, 29 now is a straightforward question on Newton's law of cooling. It's like a cup of coffee cools from 90 to 80 in T minutes. So 90 minus 80 is 10 degree. T minutes is the time. Some constant C, and we can say uh, theta minus theta naught. So when the room temperature is 20, so the average of 80 and 90 is 85, and room temperature is 20. So I get my first equation as C is equal to 10 upon T into 85 minus 20, 65. Okay, or if you want, you can say 5 2s are 10, 5, 5 3s are 15, or you can say 2 by 13T. So C is 2 by 13T. Let's call it as equation number 1. Let's read ahead. The time taken by a similar cup of coffee to cool from 80 to 60 at a room temperature, same at 20 degrees. So same room temperature, fine. So now I have the difference of 80 minus 60, which will give me 20. I don't know the time, so let's say T dash. The C value I'm going to use from here, 12 upon 13T, right? And what is the average of 80 and 60? It is 70, and the room temperature is 20. So I'm going to get two tens. So 10 upon T dash is now 50 upon 13T. So T dash is going to be 13T by 5, or actually that is matching here, 13T by 5 with option 4. Okay, so let's go to the next page. 1 2 3 4, fifth one. So that was question 29, and now we are on 30. Okay, let's do number 30. If force F, acceleration A, and time T are chosen as a fundamental physical quantities, find the dimension of energy. Okay, this is easy. There's a second question on dimension they're asking. That means it's easy. So energy is supposed to be, let's say, potential energy, mgh. So if I say mgh, so I have mass, acceleration, and distance, mgh. But we don't want mass, acceleration, distance. We want force, acceleration, and time. So these are my fundamental quantities. So mass into acceleration itself, ma, will give me force. So I have force raised to 1. Distance, what do I do with distance now? Is in meters. So how do I express that as acceleration and time? So acceleration is meters per second square, and time is in seconds. So what would be acceleration into time square? It will give me meter per second square into time square will give me second square. I'll get meters, which is what I want, distance. So this distance is nothing but acceleration in time square. So I'll have f raised to 1, a raised to 1, t raised to 2. F raised to 1, a raised to 1, and t raised to 2 is matching with the fourth option. Okay, so number 31. So there is a diagram. Find the value of angle of emergence from the prism, right? And refractive index of the glass, very interesting, is root 3. So if mu value is given to us, effective index is root 3, we will know critical angle. It will be sine inverse of 1 by mu, 1 by root 3. So sine IC is 1 by root 3, so 1 by root 3 is 0.577, right? Now 0.5, right, would correspond to 30 degrees, right? And if I take 45 degrees, it's 0.707, right? 1 by root 2. Sine 45 is 1 by root 2, which is 0.707. So my number is very close to 30 degrees. So I should have, right, 577 means maybe around, it's not going up to 45, right? 30 to 45, the gap is of 15. So I'm not going from 0.5 to 0.7. I'm not at 0.6. I'm a little bit less than 0.6. So 37, maybe 35 would be a good approximation, right? Approximately. So basically I can say this will correspond to something around 35 degrees. Okay, fine. Now let's look at this ray of light. This ray of light is coming inside. Will continue straight without any bending, right? Because it's incident on the normal. So angle of incidence is 0. So now what will happen is I can draw a normal here. So this angle is 60, so this is 30, so this is 60, 90, so this is 30. So the incident ray on the inside from within the glass is making an angle of 30 degree with the normal. So my I value is less than IC. So there is going to be refraction. Okay, so it's going to come out. So when it comes out, it will bend away from the normal, right? So it will bend somewhere like this. So what I need to find out, this becomes now the angle of emergence E. So if I just use the opposite ratio, right, then I can say mu, opposite ratio in the sense that let's just use principle of reversibility. Let's go from air to glass. Let's go in this direction. So then I have angle of incidence is E and angle of refraction is refracted ray with the normal is 30 degrees. So I will have, so I won't have TIR here, right? That is the main, why I found out this 35 degrees is to understand that there is not going to be any TIR here because I is less than 35. So we will have mu, which we know, thicker pencil. So mu, we know is 1 by root, is root 3. We know is sine E now upon angle of refraction is sine 30, which is half. So sine E by half. So the 2 goes in the numerator. So 2 sine E is root 3. So sine E is root 3 by 2. Or the E value would be 60 degrees. The sine of 60 is root 3 by 2. So, number 3. Okay. So 32. So water falls from a height of 60 meters at the rate of 15 kgs per second to operate a turbine. Okay. So height is 60 meters and the mass per unit time is how much? 15 kg per second. This is the information they have given us. Right? 60 and 15. Now, the losses due to frictional force are 10% of the input energy. So whatever is inputted, 10% of it is lost. Okay. So what is inputted here is mgh. So the efficiency here is 10% is lost. So I can say the efficiency is 90%. 10% is lost. Fine. So how much power is generated by the turbine? G is 10. Well, so the power is going to be energy upon time. Energy that is given to it is mgh, right, upon time. But out of that mgh, only 90% is going to be used. 10% is lost. So I will say 90 by 100. Okay. So I'm going to get 90 by 100. Mass per unit time is 15. G is 10. H is 60. So that's it. 0, 0, cut. So I have 90 into 15 into 6, so 15, 6 are 90. So I'm going to get 9 9 is 81 or 8.1 kilowatts, which is number 4. Okay. 33 now, match column 1 and column 2. So root, first one is column 1 is root mean square speed of gas molecules. So RMS speed is root of 3 RT by M, right? V RMS. Pressure exerted by ideal gas. So pressure exerted by ideal gas is P. So then I can use the formula 1 by 3 rho C square or rho RMS square. So 1 by 3 rho density would be mass upon volume. So small n I think is per unit volume. So number of molecules into M will give me total mass upon volume, and V square is RMS square. So A here should match with Q, and B should match with P. So A, Q, and B's P is basically option 1. But still, let's continue and check. C, average kinetic energy of a molecule. Oh, so kinetic energy per molecule is 3 by 2 kT, 3 by 2 kBT. So C should be S. Yes, that's what it is saying. C is S, right? C is S. And total internal energy of 1 mole of a diatomic gas. Okay, so 1 mole diatomic is 3 by 2. Sorry, diatomic is Cp is 5 by 2. So yes, it should be R. Correct. Right. So 1, the first option itself is correct. Okay. Number 34. A particle is released from height S from the surface of Earth. Okay, so it is at a height S from the surface of Earth. At a certain height, its kinetic energy is 3 times its potential energy. Okay, so it gains kinetic, it loses potential, and at a certain height, some new h, let's say, right? Ke is 3 times the potential. That means it will be quite close to Earth because we will have a high speed. The height from the surface of the Earth and the speed of the particle at that instant are what? So I guess what we could do here is, let's just use mgh for reference. So 34. Okay, let's go to the next page. Right, so I'm releasing from height h, from height s, and somewhere in between, let's say here, the Ke is 3 times its Pe. So let it be some height h. Okay. So one thing is clear, that kinetic plus potential has to be constant. So Ke plus Pe is going to be mg height s, right? Because the total energy here was released from height s. So mgs instead of h, we will say mgs, and that was only potential. There was no kinetic. It was released. So Ke plus Pe is mgs. Ke, by the way, is 3 times Pe. So 3 times Pe plus Pe is mgs. So 4 Pe is mgs. But at this point here, what is its Pe? It's mgh. So 4 mgh is mgs. So I have h is basically s by 4. So if they are asking the height from the surface of Earth at that instant, right, when this happens, is s by 4. So that has to be this, right? So option 1 is gone. Now we also have to find out the speed of the particle at that instant. Fine. So let's say v square is equal to u square plus 2s. If I use that, right, the initial u is 0, final v we need to find out. This displacement would be s minus h, and the a value is g. So v square u square 2as, let's use this. So u is 0, acceleration is g, and the, it's not literally s here. Let's just say displacement 2a would be st. The displacement is s minus h. I don't want to use the letter s because the displacement is not s, it is s minus h. And h, by the way, is s by 4. So I have 2g, 1 minus 1 by 4 is 3 by 4. S. 2 2s are. So I have 3gs by 2. This is v square. So v is 3gs by 2 square root. So I have 3gs and 2 is inside the root, right? Yeah, it is inside the root, not outside the root. So it has to be this option. Okay. Number 35. We have space, yes. Two charged spherical conductors of radius r1 and r2, okay, are connected by wire so their potential will become equal. Then the ratio of surface charge densities of the sphere sigma 1 by sigma 2 is what? Okay, so this is electrostatics, but easy. That's why I always say should never have any favorites, because even a difficult chapter can have easy MCQs like this one. So radii to charge spherical conductors shared a sufficient density. So what was the initial things mentioned? Okay, fine. So then I can say surface charge density. Okay, so if I'm joining them by a wire, that means V1 is going to become equal to V2. So what is the potential on the surface of this sphere? 1 upon 4 pi epsilon naught. Let's say Q1 is the charge on the first sphere, Q2 on the second sphere. So Q by potential I want, so it should be R1. And here it will be equal to 1 upon 4 pi epsilon naught Q2 by R2. So basically I have Q1 by Q2 is equal to R1 by R2. Call this as 1, and now we will use this to find out what do they want, the ratio of charge density, right? So sigma is charge upon area. So I will have Q, what is the area of a sphere? 4 pi r square. So if I want the ratio of sigma, is going to be, I will say sigma is proportional to Q by r square. 4 pi is a constant. So therefore, well, sigma 1 by sigma 2 would be Q1 by Q2 and it's inversely proportional. So R2 by R1 ka square. So what is Q1 by Q2? Q1 by Q2 is R1 by R2, and this is R2 square, R1 square. So I get basically R2 by R1. Very simple question. Alright, so now we enter section 2. So question number 36. Let's go to the next page actually. Oops. Yeah. So a point object is placed at a distance of 60 centimeters from a convex lens of focal length 30 centimeters. So this is a convex lens, focal length is of 30 and I am placing it at 60. So please note that this is a lens of focal length 30 centimeters, and the object is placed at 60, that is 2f. So if the object is at 2f, the image is also at 2f. So the image would be produced somewhere here. That image becomes the object for this next thing. So let's read ahead. If a plane mirror were put perpendicular to the principal axis at a distance of 40 from it, then the final image would be formed at a distance of what? So very simple. So just now I said the first image is going to be produced here, right? Somewhere here. So what becomes the object distance u for my plane mirror? So u becomes actually plus, right? So this was 60, right? The whole thing was 60, and this is 40, so this much is 20. Right? Let me show it here itself. It's 20, so it's plus 20. And for a plane mirror, we know that v is minus u, so it's going to be minus 20. So it's going to be minus 20 means it's going to be somewhere here, right? So is it at 30 centimeter from the plane mirror? No, it's at 20. Virtual image, yes. So 30 is wrong. 20 centimeter from the plane mirror, it would be a virtual image. Yes, right. 20, it is at 20 centimeter and it's a virtual image. No, wait. Virtual image would be behind. It's here, so it's not a virtual image. It's a real image. Right. If you talk about the rays of light, then again reflect and meet here. So it's a real image. So 20 centimeter from the lens, it would be a real image. So it's number 3. Okay, 30 is wrong. So then let's go to the next one. Transformer. So a step down transformer connected to an AC mains supply of 220 volts. So E primary is 220, is made to operate at 11 volts. So E secondary is 11 volts. 44 watt lamp. So that is output power. Output power or secondary power. P secondary is 44 watts. Ignoring power losses in the transformer. That means it's an ideal transformer. So input output both are same. What is the current in the primary circuit? Not I primary. Oh, this is very simple. So E secondary is E secondary I secondary. So I will get I secondary E secondary upon E secondary, which would be, what is the secondary power? 44 upon 11, 4 amperes. Now we will simply use the formula EP upon ES would be equal to IS upon IP, right? Because the powers are equal. There are no losses. So IP is going to be IS into, or even if you just cross multiply, you see, secondary power is equal to primary power. That's what we are trying to say. So IP is going to be IS into ES upon EP. What is IS? IS is 4, ES is 11, and EP is 220. So 11 2s are 4 5s are. So I primary is basically 1 by 5 ampere or 0.2 amperes, whatever they say. So they said 0.2. We'll go with that. Okay. 38. So they're telling me there is a car, it starts from rest, and starts from rest means I will say U 0, and accelerates at 5. At t equal to 4, a ball is dropped out of a window by a person sitting in the car. Okay. What is the velocity and acceleration of the ball at t equal to 6? There is 2 seconds after that. So the acceleration is going to be g, right? Because the only force acting now on the ball is neglecting air resistance, friction. right? The only force acting is G. So there is only one option there with G, and that is option 2. So my answer has to be number 2. So again, this was a time waster question. But if there are multiple options, then how will you prove that the velocity is going to be 20 root 2? So let's find out. So first of all, the car is starting from rest and accelerating at 5. Then after how many seconds? 4 seconds. So at 4 seconds, what will be the speed of the car and of the ball, which is yet to be dropped? Okay, it's not yet dropped. So I'll say V is equal to U plus 80. So U is 0, A is 5, and T was at 4 seconds, 20 meters per second. So this becomes the original speed of the ball as well, right, at 4 seconds. And this original speed, please note, is horizontal. So now my ball is having a speed of 20 meters per second. Now after 2 seconds, its horizontal speed will continue to remain the same, assuming no air resistance, right? But it will also gain a vertical speed. And what will be that vertical speed? So now I will say V vertical is U vertical plus 80. The U vertical is 0. The acceleration is G. And the time is now only 2 more seconds after 4 seconds, right? They are saying at 6 seconds. So 4 plus 2 gives me 6. So I just want for 2 seconds. So it's going to be 20. So I have a speed of 20 horizontal as well as vertical. The resultant has to be 20 root 2, which is what we have written here. Okay. 39. For the given circuit, the input digital signals are applied at the terminals ABC. ABC. What would be the output at the terminal Y? That's here. Okay, fine. So I have 0, 0, 1. Okay. So the difference in these waveforms is this is always 0, this is always 1, right? Always low voltage, always high voltage. And this is fluctuating, right? This one and this one. Okay, so let's think about it. First thing I'm giving is 0, 0, 1. So if I give 0, B 0, C is 1, what will I get? 0 into 0 will give me 0. 0 into 1 will give me 0, but not 0 will give me 1. And 1 plus 0 is 1. So I'll get a high voltage. So at the beginning itself, I should have a high voltage. That is happening in option 3 as well as 4. So 1 and 2 are got. Now let's just check at the next instant what happens. Because option 3 is saying it is high and option 4 is saying it is low. So that's it. The next instant itself will give us the answer. So it is going to be 1, 0, 1. Okay, so let's change it. 1, 0, 1. So I now have 1, B0, this is 1, right? Just verify that again. 1, this is 1, this is 0, this is 1. Yes. Okay. So what will I have? 1 into 0 and get is 0. 0 into 1 is 0, but not 0 is 1. Again, I am getting high voltage. So that's it. It has to be option 3. There's nothing more to verify. Still, if there were multiple options which were clashing, then let's check once more. So the third time instant is this now. So 0, 1, 0. So I have 0, 1, 0. So 0 into 1 is giving me 0, 0, 1 into 0 is 0, not 0 is 1. Again, I get high voltage, right, which is matching with 3. So I think there is no need to go any further than this, right? Option 3 itself will give us the answer. Okay, option 4 is a numerical. We don't have space, so let's go to the next page. Yeah. So question 40. Right, we just finished 39, so we're now on number 40. So series LCRs are containing a inductor is of 5 capacitor is 18 micro, resistance is 40 ohms, the voltage given is 230 volts. So the angular frequencies of the source, because it's a variable frequency source. So what is the source frequency at which power transferred to the circuit is half the power at resonant frequency. See, at resonance, the power transferred, let's call it as PR, is ERMS IRMS, or ERMS square by R, E square by R. Now, at some other frequency, right? At other frequency, the P value is ERMS IRMS, or I can say ERMS square by R into cos phi, which is R by Z. Okay. Or this is nothing but this term here is the same as this PR into R by Z, and they are telling me half power at resonance, that is PR by 2. So basically I get R by Z is 1 by 2, or Z is 2R, or Z square, therefore 4R square, or Z square is nothing but R square plus XL minus XC the whole square. So I will have 4R square minus R square is 3R square is XL minus XC the whole square, or XL minus XC is nothing but root 3 times R, correct, if we take square root on both the sides. So now our job is to find out the omega value. So we know the value of R, so let us just substitute the values or the formula for XL and XC. So we will have omega L, omega 1 by omega C is root 3 R, okay, and R value is known to us 40, so 40 root 3. So what we could do here is take LCM, so we can say omega in L into omega C will give me omega square LC minus 1 is root 3 R, or I will have omega square LC minus 1 is root 3 R C omega, because omega is the variable here. So let me say LC omega square, LC into omega square, right? Minus root 3 RC times omega, right? This term, if I bring it here, will become negative, and then minus 1. So I have a quadratic in omega now. So before I find out the quadratic, maybe I can divide by LC. So I'll get omega square minus root 3 RC upon LC. Right? I divide by LC, so here I get 1. So CC cut this times omega minus 1 upon LC is equal to 0, or I have omega square minus root 3 R by L, omega minus 1 by LC 0. Let's find out the roots. So I'm going to get omega is plus minus or minus B, so root 3 R by L plus minus square root of B square. So this is going to be 3 R square by L square minus 4 into A, which is 1, into C, which is negative, so plus 1 by LC divided by 2A, and A is 1, so 2. So what do I get? I have root 3 R by 2L plus minus this 1 by 2 goes inside, becomes 1 by 4. So I have 3R square by 4L square plus 4 by 4 will cancel off, I'll have 1 by LC. So that's it. Now we can plug in the numbers. I believe R was 40 and L was, I think, 5 Henry, plus minus 3, 40 square what is L? 5. So 5 as a 25. Plus 1 upon L is 5 and C was 80 micro. Micro is minus 6. Goes in the numerator, becomes plus 6. Okay, let's solve this. 5 2s are 10. So 4 root 3. 4, this becomes 10. So I have 400, or it can be written as 4 3s are 12 into 100, and 100 by 25 is 4. So 12 4s are 48. 1 0 goes. So I have 8 5s are 40. Or let's just keep it as 8 into 5. Then I have 10 into 10 raised to 4, which can be written as 100 into 10 raised to 2. 5 zeros basically. So 1 2 3 4 5. Now 5 2s are 10, 2 4s are 8, and 4 25 is 100. So I have 48 plus 2500. So I have 2548. 2548. And 4 root 3. What is 4 root 3? It's 4 into 1.732. So how do we find this out now? See, root of 2500 would be 50. And what would be square of 51? So if you just do a rough calculation, 51 into 51, or it's 50 plus 1 square, right? So it's 50 square, 2500, plus 1 square, plus 2 into a into b, 2 into 50 into 1 is 2 into 50, so 100. So I have 2500 plus 100 is 2601, whereas my number is 2548. That means my answer here is going to be something around 50.1 for the square root, right? And then I also have 4 into 1.732. So 1.1.5 times would be 6, so a little bit over 6, so maybe 7. So plus minus this, and then plus 7. I'm just doing a very rough calculation here. So I would get somewhere like 57 and 43, something like that. So, you know, this would be the best option, 43 and 57. So close to likely to be 42 and 58. Okay, 41 now. So let's go to the next new page. Here. So 27 drops. So number of drops is 27. Please note it is 3 cube. 3 cube. 3 3 is 9, 3 is 27. Okay. Of the same size are charged at 220 volts each. Okay. So if the potential is given, which is 220, right? What would be the charge? It would be 1 upon 4 pi epsilon. Let's just call 1 upon 4 pi epsilon naught as k. Okay, so I'll have 1 upon 4 pi epsilon naught, which is some constant k, into q on each drop, potential, so r, or I should say small r, because we're talking about the small drops. So what would be q? It would be 220 small r by k. Please note k is 1 upon 4 pi epsilon naught, which is 9 into 10 is to 9. Call this as equation 1, or rather you can call it as 2, this is 1. Now they combine to form a bigger drop. So if they all combine to form a bigger drop, what is the bigger drop's potential? Yes, this is V small r. So what is V capital R? Well, that would be 1 upon 4 pi epsilon naught, which is k. What would be the charge? So it would be n times q, because all of these charges cannot be created or destroyed, right? So they will all add up. So nq by the bigger radius r. Now we know for one drop to many drop, right? Capital R is nothing but, we can write it as small r n raised to 1 by 3 into small r. Capital R cube is n r cube, right? Or if you want to prove it, yeah, if you forgot that, and you can very quickly prove it, 4 by 3 pi r cube, the volume remains the same. So n times 4 by 3 pi small r cube. So 4 by 3 pi gets cancelled off. So capital R is n raised to 1 by 3 small r. Yeah, that's what I was saying. So you have k n q upon n raised to 1 by 3 small r. So that's it. So the potential on the big drop would be k into n upon, so let's just put the value of n. N is 27 and n raised to 1 by 3 is 3. Cube root of n is 3. Yeah, cube root of 27 is 3. Okay, what is small q? We just now wrote it as 220 times small r by k, and again divided by small r, so I don't need to know small r. K gets cancelled off. 3 nines are, so I have 0, 9 to the 18, 9 to the 18 is 1, 19, so many ones, 1980, which is this option. Okay, now the next one is probably the easiest question, I would say, of the paper so far. They are simply asking us, it's a current divider. So the I1 value here will split into I2, I3. So as per the formula for current divider, we want I3 by I1. So I3 is simply going to be I1 into the total current I1 into the opposite resistance, which would be this fellow R2, upon the addition of the two, which would be R2 plus R3. So my answer R3 by I1 is going to be R2 upon R2 plus R3. So that is this one. Okay, very simple question. Okay, then let's do the next one. This is 43. So we have a ball of mass 0.15 kg. Okay, so the mass value is given to us 0.15 kg. Is dropped from a height of 10 meters. Okay, fine. And it strikes the ground and it rebounds to the same height. Wow, so that means E is 1. There is no loss of energy, kinetic energy. So the magnitude of the impulse imparted to the ball is nearly how much? And G value is 10. Okay, so it would be basically change of momentum. The impulse, the J value. So since it rises back to the same height, there is only a change in the direction for the speed. The ball falls from a height h, it comes here with a speed, let's say u, and it bounces back up with the same speed u, only then it will be able to reach the same height h, right? So the change of momentum, right, the change of momentum delta p, because that's the impulse, f into t, is 2 mu, mu in one direction and the other direction, so 2 mu, right? Or if you want with the sign, you have to say mu, minus mu minus of minus mu minus mu, so that will give me minus 2 mu. I'm just ignoring the sign. So 2 mu. So I need to find out u, the speed just before collision. So it would be root 2 gh, right? Or v if you want to call it as v, root 2 gh. Or v square is equal to u square plus 2s. So initial was 0. The final I'm calling it here as u. So u square 2a and height is h. So u is root 2 gh. So that's it. The answer is 2m root 2 gh. So this number we need to find out because they want a number, right? So 2 into mass 0.15, let's write it as 15 by 100 into root of 2 into g into what is the h is also g. So this would be basically 15 to the 30 by 100 into root of 10 into 10 is 10 root 2. So I have 3 root 2. So 3 root 2 would be 3 into 1.414, which will give me 4 3 are 12, 3 1 is 3 plus 1 4, 4 3 are 12 again, and add 4, so 4.4242. So 4.2 is this one. Okay, very simple question. So that was 43. Uniform rod of length 200 centimeters, so that is this one, and mass 500 grams. So I should draw one weight here in the middle because it's uniform. So 500 grams is half kilo. So half into G, or G by 2. G by 2 is the force. Okay. It is balanced on a wedge. Okay. Placed at 40 centimeter mark. So here is the wedge. A mass of 2 kg is suspended from the rod at 20 centimeters. Okay, fine. And another unknown mass M is suspended from the rod at 160 centimeters. Okay. Shown in the figure. So find the value of N such that the rod is in equilibrium. So if the rod is in equilibrium, summation of all torques, not just forces, all the torques is also 0. So how many forces do we have? Um, um, so let's consider this as the axis of rotation, so that the normal reaction torque can be neglected. So let me draw that force here. Okay, so these are all the forces. So this is a classic question of drawing the table. So we will talk about force, we will talk about perpendicular distance, and we will talk about torque. So how many forces we have? First force we have is 2 kg weight, which is 2g. Second force we have is normal reaction, that is N upwards. The third force we have is g by 2, right? The mg of the scale itself, right? Which is half kilo. 500 grams is half kilo. The fourth force we have is this mg. This small m I don't know. Okay. Perpendicular distance is the distance between line of action and the force. So 40 centimeter is on the line, so it's 0. 2g. So this line, how far is it from this line? Perpendicular distance. So the gap is 20 40, so 20 centimeters. So let's keep it in centimeters only. There's no problem. Units will get cancelled off. G by 2, how far is it from the axis? So that this is at 50 centimeters, this is at 40, so the gap is 10. And this one is at 160, and the fulcrum is at 40. So 160, no, sorry, wait. This is a 200 centimeter scale, this is not, this is going to be 100. Okay. So if this is 100, then this is 40, then the gap is 60, sorry. And mg, right, this is at 160, not 100, it's not a meter rod, it's a 2-meter rod, 2-meter scale. So I hope to get this correct. 20 40, yeah, correct. So 160 minus 40 will give me 120. So here the torque is 0, here the torque is 20 into 2, so 40g. So we have 40g. G by 2 into 60, right? So 60 by 2 is 30g, and this is 120 mg. Now let's consider the direction. Please note, all anti-clockwise torques are considered by default as positive. So um, this about this as the axis, right? This point is the axis. This torque, this G by 2 will rotate it this way. This will also rotate this way. So G by 2 and mg both are going to create a clockwise torque. So G by 2 is negative, mg is negative, and 2 kg is the only torque which is going to create an anti-clockwise torque. So it's going to be positive. That means this 40G has to be equal to addition of these two. So 120 mg plus 30G. They are the clockwise and 40G is the anti-clockwise. So 10G is 120 mg. G cut 0, 0, 1. M is 1 by 12 of we have taken in SI units. So kg. The mass was in SI units. The distance doesn't matter here. So answer has to be number 2. Okay. 45. A uniform conducting wire of length 12A and resistance R is wound up with a current carrying coil in the shape of a triangle and then a square. Equilateral triangle of side A. Then how can I have 12A? So I'll need multiple terms. So 3A, 3A, 3A several times. And square A, so 4A 3 times. Yeah. So the magnetic dipole moments of the coil in each case respectively. Oh, this is very easy. So I'm going to get 45. In case 1, capital M is NIA. So number of turns. How many turns did I have? 3A. So 3A, 3A. 3 into 4 will give me 12A. So 4 turns I will have. 4 3 is 12A. Current is I. So I guess the current is the same. And area of a equilateral triangle. So you can say half base and the height would be what? Equilateral triangle. So this is A, this is 60, this is 30, this is A by 2 rather, right? This is also A. So what is the height? It is 60 के सामने वाला, so sin 60. So root 3 by 2 is height h upon hypotenuse. So root 3 by 2A. So half into base into height. So root 3 by 2A. So what do I get? I get 2 2s are 4. I get root 3 I A square. This is matching only with option 3 here. You see carefully. So I think we have got the answer, but still again, just for your clarity, let's find it out for the square as well. So in the second case, the n would be, this was 1, then would be m2, again NIA. So now we have how many turns? 4A, so we will have only 3 turns. I, and area is a square. So 3IA square, there is absolutely nothing to worry about yet. Okay. Then the next one, 46. Two conducting circular loops of radii R1 and R2 are placed in the same plane with their centers coinciding. They are in the same plane, coplanar, and centers are coinciding. That means they are concentric. If R1 is very large compared to R2, like this, then the mutual inductance M between them will be directly proportional to what? So the formula to be used here is basically M. It's black. Okay. M is mu zero concentric coils we have. So mu zero pi n1 n2. So all these are constants. So let's just ignore the constants. We will have small r square upon 2r. Again 2 is a constant. So now here capital R is the bigger radius, small r is the smaller radius. So now who is small here? We have R2 is the smaller one. So I will have R2 square upon capital R. But R1 is very large. So R2 square by R1 would be option 2. But then what about that ratio? I guess we will have to just take it in this one itself. Right? The second option R2 square by R1 because that is there. if I neglect, if I consider that R2 is very small, then R2 square is negligible, right? Then negligible upon a very big number. Yeah, I don't think so. We can further simplify it. So this fact that R1 is very large compared to R2, just neglect this, and then this is the answer. Okay. Next one, 47 space. From a circular ring of mass m and radius r, an arc corresponding to a 90-degree sector is removed. So it will be mass m by 4. Right? 90 degrees is 1/4. Now the moment of inertia of the remaining part of the ring about an axis passing through the center of the ring and perpendicular to the plane of the ring is k times mr square. So what is the value of k? Fine. So the mass is going to be, the radius is going to be remain the same. The mass is going to become 3/4, right? So I will have, if you consider this as the ring, okay, and then 1/4 of it is removed. Right? So then, how much was the moment of inertia of the entire ring about an axis passing through center and perpendicular to the plane? They have said center of the ring and perpendicular to the plane. Yeah, so that is mr square. So if I had the entire ring, then I would have mr square. That mr square, if I consider as, if I divide that by 4, so 1/4 will be the contribution of each side of each sector, right? Each arc, right? So 1/4 mr square, 1/4 mr square, 1/4 mr square. Now this remaining 1/4 mr square, that part is gone. So what remains is 3/4, right? So the k value should basically be 3 by 4. Very simple MCQ. Okay. A particle of mass m is projected with a velocity v, which is k times ve. Right? K is less than 1, v is the escape velocity. So it's projected with a speed less than the escape, so it's not going to escape. So what is the maximum height reached by the particle? Okay, this is very standard question of gravitation. So again, '48. So when it is projected from the surface of Earth, it has a kinetic energy how much? Half mass of the particle into its velocity, which is kve a square. So k square ve square. So ve square would be 2gm by r. Potential energy on the surface of Earth will be minus g capital M small m by r. Right. And when it reaches a height h, its kinetic energy is 0 and its potential energy is gmm by r plus h. So first of all, we can take something common and cancel off. Gmm, gmm, gmm. So I have 2 and 2 also gone. So I have k square by r, the first term, minus 1 by r, the second term, is minus 1 by r plus h, or let's switch sides. So I will have 1 upon r plus h, right, would become equal to 1 by r minus k square by r, 1 minus k square by r. It was k square minus 1, it has now become 1 minus k square, right? So r plus h would be r upon 1 minus k square, or h would be r upon 1 minus k square minus r, which would be, what do they want it in this form? No, they want only one term. So let's take the LCM as 1 minus k square. I'll have r minus r into 1 minus k square. So I can take r common, and I will have 1 minus, open brackets, 1, and minus of minus becomes plus k square upon 1 minus k square. So this is going to become rk square upon 1 minus k square. So rk square upon 1 minus k square, this is matching with the second option here. Or is it 1 minus k the whole square, or was it? No, it was 1 minus k square. Yeah, so this one is quite confusing. Okay, it's not 1 minus k the whole square. It's 1 minus k square. Okay, 49, second last question. A particle moving in a circle of radius r with a uniform speed takes a time t to complete one revolution. So that is its time period. Correct. Now, if this particle were projected, okay, so we can get its speed now, uniform speed. So if this particle were projected with the same speed, so what is that same speed? Let's write that first before we move ahead. So that v would be r omega, right? Or omega is 2 pi by t. So r into 2 pi by t. Radius is r. So now with this v, it is projected with the same speed at an angle theta to the horizontal. The maximum height attained by it equals 4r. Okay. Then the angle of projection theta is given by what? Okay. So maximum height. So we know this now. The v value is, as I said, 2 pi r. Yeah. So 2 pi r by t, distance upon speed, we can consider. And after that, it has been projected, and the height, the maximum height is 4r, and the maximum height attained by it equals 4r. Okay, so the h value is 4r. Now we know the formula for h is what? U square, or in this case v square, sine square theta by 2g. Okay, so we have sine square theta now is going to be 4r into 2g upon v square, or we have 8rg upon v square, and v square is 4 pi square r square upon t square. So we can cancel off the r. You can say 4 to the 8. So I have sine square is 2g t square upon pi square r. And if this is sine square theta, sine theta is root of this, so sine inverse of that. Sine inverse of the root of this thing, 2g t square upon pi square r. So sine inverse means not these, 2g t square upon pi square r. This is exactly matching with option number 2. Let's verify once more. 2g t square upon pi square r. Yes. Okay. And finally, the last question. In the product, F bar is Q V bar cross V bar, which is Q V bar cross B is considered as a BI. BI cap plus BJ cap plus B0 K cap. Okay. So for Q is 1, V is this, and F is this. What will be the complete expression for B? Is it 8866 minus 8 minus 8 minus 6 minus 6? We have to figure that out. And what is that B naught? Okay, so this is a very simple MCQ. All we have to do, see, Q is 1. We will have to take the cross product of this V bar and B bar. So what is V cross B? So we'll say I, J, K. This is simple maths MCQ actually. V is given to us as 2I, 4J, 6K. And B is given as BI, BJ, and B0K. So let's take a cross product. So I'll take I cap. I will have 4B0 minus 6b, then minus j cap, I will have 2b0 minus 2b0 and just a second, 6b. Okay, and k cap would be 2b minus 4b, or basically this is my into 1, right? Q is 1. Q is 1. So if I just multiply it by 1, it doesn't matter. So I'll get my F. That means if I compare it with 4i minus 20j and 12k, I should get 4b naught minus 6b is 4. First of all, let's equate the third one because we're straight away getting the answer here. 2b minus 4b is minus 2b, k cap is 12, right? So b is 2 6, so minus 6. The b value is minus 6. So straight away we get the answer is actually 4. Right? The answer is 4. But still, if you want to verify that, put that here. So you will get 4b naught is equal to 4 plus 6 times b, but b is minus 6. So I will have 4 minus 6 is 36. So I will have 4b naught is minus 32. So b naught is 4 8. So minus 8, which is matching here. Okay. So if you ask me, I would say, again, I will repeat, everything is there in the flashcards. If you had memorized everything, right? Even the vernier caliper screw gauge question, that was a simple logical question actually, right? It was a very simple thing. So everything is there in the cards, right? And not a very easy paper, but some of them were really simple MCQs, okay? But not, I would not even say a medium level paper, a little bit in between easy and medium. Yes, I would rate it like that. Okay, so please verify your scores, and you can tell me how much marks you are expecting in physics especially. Okay, thank you, bye bye, best of luck for all your future endeavors. It was a wonderful experience teaching all of you. Thank you.